Hello everyone, this is Dr. Sharif and today we'll be learning how to get the reactions in this frame. For that frame we have a pin support at A, so there is a reaction, we call it Y at A. And for a pin support, of course, also we have another horizontal reaction, we call it X at A. And then we have a roller support at B, but it is inclined, so the reaction will be only one reaction which is perpendicular to the support, and we call it F at B. For this F at B, it is better now to get the resultant, vertical and horizontal resultant, and to do that we need to get the angles. Okay, so we have a triangle here. This triangle, it is 1.5 meter and 2 meter, and therefore we can get this angle. It will be 1.5 divided by 2 inverse tan. Let's do that. 1.5 divided by 2 equal inverse tan. It is 36, so the angle here is 36.87, okay, and therefore this will be exactly the same angle, which is 36.87. Therefore the force here will be FB cosine angle, and here FB sine this angle, which is, let's say it is theta. Okay, so cosine this angle is 0.8, and therefore this here, the force that we have it here, it will be 0.8 FB, and here it will be 0.6 FB. So we have two forces, both of them are depending on the FB, but the component is 0.8 and 0.6. And in addition to that, we have to find the resultant force that's here from this uniform load. So the resultant force here is at the middle, and the value will be 10 times 3 equals 30 kilonewton. Distances here will be 1.5 meter and the other 1.5 meter. Okay, so now we are ready to start getting the reactions. Let's do that. And we can take summation of force in X direction. We will have two unknowns, 0.6 FB and X at A. So let's use another option. If we took summation of force in Y direction, we have the YA and the 0.8 FB. So also again, it will not work. If we took a moment at this point, you still have two unknowns. But if you take a moment at this point, you have the 0.6 and 0.8 FB. It's both of them are depending on FB, so we have only one unknown, which is called FB. It means we can, by taking moment at A, we can solve and get the value of FB. Let's do that, but before, let's get the dimensions that we have it here. How much is this dimension? It is 4 minus 2 meters. It is also 2 meters. Now we are ready to start making our calculations. We are going to start of summation of M at A equals to 0. Okay, therefore then you have 30 times 1.5. We start by 30 times 1.5. Okay, now minus this force, which is 0.6 times 2 meters, so minus 0.6 FB times 2 meter minus 0.8 FB times this distance, 1.5 plus 3.5, the total is 4.5, all equal to 0, and therefore we can get the FB equals how much? Let's do that. It will be 30 times 1.5 divided by 0.6 times 2 plus 0.8 times 4.5, all equals 9.375. 9.375 kilonewton in the same direction that we assumed, and therefore this will be our first force. From here we can get directly the 0.8 FB, the components, equals, so this is times 0.8, this will be 7.5, and also the 0.6 FB equals 9.375 times 0.6 equals 5.625. So these are the two components. Here it is 7.5, and this value here is 5.625. Okay, now we are ready to continue, and if we take summation of Fy equals to 0, therefore y at A, which is still unknown, minus 30, which is the force that we have it here, plus the component 7.5 equals to 0, and therefore we can get the y at A in this case equals 30 minus 7.5, it will be 22.5 kilonewton going up, and this will be the y at A. Then summation of Fx equal to 0, therefore x at A minus this 0.6 FB equal to 0, so it means minus 5.625 equals to 0, therefore the XA equals 5.625 kilonewton, and is going to this direction as we assumed. So now we calculated all the forces. Let's write them here on the drawing. So YA is 22.5, X at A is 5.625, and then we have already the other two components. Now it is finished your problem, but you need to make a check. It is always important to make a check to ensure that your solution is okay. To do that, let's take a moment at B, because we never took it before, and we'll see if it is 0 or not. So taking a moment at this point B, clockwise rotation will be positive, so counterclockwise will be negative. We are going to start by minus 30 times, what is the distance here? 1.5 plus 1.5, so the total distance is 3 meters. Okay, then minus again XA times 2 meters. Okay, this is XA times 2 meters. XA is 5.625 times 2 meters, then plus YA times this distance, which is 4.5, so YA 22.5 times 4.5, and let's see if it is 0, it means our solution is correct. If it is not 0, it means there is something wrong. So 30 times 3 minus 5.625 times 2 plus 22.5 times 4.5 all equals 0. So it means our solution is correct. I hope that this is useful. Thank you.